Welcome to week 13. We're almost done, a couple weeks left. So we're going to continue with chapter 5 this week on rational equations, rational functions. Our goal is a couple things. One, to be able to solve a rational equation algebraically, and graphically you probably already know how to do that if you kind of look at some other things we've done this semester. We're starting with a situation that is giving us a function for the amount of blood in our blood alcohol in our bloodstream. So the blood alcohol concentration for however many beers we drink per hour. Okay, so if we look at this function right here, that they're giving us B equals 600 over n divided by W times 169 plus 0.6 n. So n is our number of beers, and this depends on two things. B is dependent, our blood alcohol is dependent on number of beers we consume per hour, and also our weight. Okay, so for 1a, replace W with your body weight, and we're going to use that to fill in our table. So I would never give anybody my weight here, so we are going to use the one that the book uses. Okay, so the book is using a W of 200, so I would just use the same thing. You can also fill it out for your body weight if you want. No big deal, we can do it with either one. But I'm going to use the one that the book is using of a weight of 200. Okay, so if I rewrite that equation, I have 600 over n divided by 200 times 169 plus 0.6 n. Okay, so eventually we're going to be able to plug in a value for B and figure out how many beers is it going to take to get this blood alcohol. Okay, that's where we're going. That's what we're trying to do to solve these rational equations. First thing we're doing is filling in just n values and finding the corresponding B. So I've already made the table. Okay, so stop the video, do these calculations, plugging in n equals 1, 2, 3, all the way to 10, which I don't know how that's even really possible to drink those 10 beers. So then stop the video, fill those out, come back, make sure you've got the right values, and then we can continue with that. Okay, so now number 2, according to this model, how many beers can you consume in 1 hour without exceeding the recommended legal measure of drunk driving? So it says in the beginning that all except a few states have the legal limit of 0.08. So they're really asking us, where does it happen? Okay, so if you look in between here, it happens somewhere in between 4 and 5. So 4 is the most you can have per hour to be, this is for just a 200-pound person. Once you go over 4, you start to go over the blood alcohol, the legal limit of 0.08. So now we're going to look at changing the weight to 232, seeing if that has any impact on, or how much impact it has on the blood alcohol concentration. So I rewrote my equation in terms of, now I changed my W right here. I changed it to 232. And again, I just rewrote my table, doing the same thing that I did above. So you should stop right now to get these values, and then catch up with me, turn the video back on when you're ready. Okay, so now let's see. What is a practical domain of the blood alcohol function? So what x's can I plug in for this? Okay, so really, we did the table for 1 through 10. I am able to plug this in for 0. Okay, so my domain would be anything from 0, and then let's see what's a reasonable practical domain. We want to be under the legal limit, so you could say 0 to 4. Depending on your weight, it might be 0 to 3, it might be 0 to 5. Okay, so that can vary, but it's not going to be 0 all the way up to infinity. Does the weight of a person have an impact? It definitely does. We saw that from the two that we just did. The first one was 200-pound person, the second was 232. So yes, the heavier the person, the more beers they can consume and be under the legal limit. And be under the legal blood alcohol concentration. What's the vertical intercept? Okay, so if I went and plugged in n equals 0, what would I get out? Whoops, that's not what I wanted. We would have to have a W in there, depending on if W is 200 or 232. It wouldn't matter here. I would end up getting a b out of 0. So that's my vertical intercept. So the vertical intercept is 0. If have 0 beers, your blood alcohol is 0. And that's obviously, that is a reasonable one. That makes sense. That's exactly what it should be. So this function works for that. So the next thing is just doing a sketch. So I already set up my graph. So take a minute, set up your graph with the scale that I've used. And I've just plotted the first 5 points of it. And if you look at that, my first 5 points, and actually we would have 0, 0 on there as well, my first 5 points look linear. And it is possible when you zoom in on just part of a function, it could appear linear, even though we know looking at that function, it's not. It's a rational function. Okay, we've got variables in the denominator. So it does appear linear, but it's only for this little window. If you go, the next step here is to actually graph this on your graphing calculator. Okay, so take your graphing calculator and take a look at the full function, not just from 0 to 5 like we did up above. And then you'll see that over the full, all the x's that we can plug into this, it's not linear. It's just linear for that part that we graphed. And that happens a lot of times. So let's move on. So now our goal is, the 232-pound football player is given a breathalyzer test. The result's 0.05. And we're going to try to backtrack and figure out how many beers did he consume in that previous hour. So we're given a B value of 0.05. Okay, so I'm going to take and plug that in. And if you start to look at this, this is where we're going to start solving these kinds of equations. Okay, because now I'm solving for n, not plugging in an n and getting out a b. Okay, so that's our goal. We want to be able to solve something like that. I think a little bit simpler ones, or actually we're going to start, the next step is to do it graphically. So you've done this before in many different types of functions, and when you can't figure out how to solve it algebraically, then this would be your fallback way. So what I did was I graphed our first function, the one that we just had, the y1, that 600n over, that whole big denominator. I put that in y1. And in y2, I put in the 0.05, and I'm looking for where they intersect. Okay, I'm looking for that spot right there. Okay, so if you do this, you've done this before, go on, find the intersection of it. You'll find that for the blood alcohol to be 0.05, it means that X had to be about, let's see, 3.3, we'll say 1. 3.31. So that would be how many beers were consumed in that hour before that this person took the breathalyzer test. So our goal really now, though, we want to be able to do this algebraically. So we're starting with a little bit simpler examples. Okay, we've got this, solve the equation 16 over x plus 3 equals 2. So they're stepping us through the process. So I'm going to let you go through that process on that one, and I'm going to step you through one where I can show my work on the next slide. Okay, so now let's go down to one. Okay, all that work is done for you. So let me go down to one like 5b that looks similar, and I can show you my work. So the first thing you're going to do, we want to get that x plus 2 out of the denominator. So I'm going to multiply both sides by this x plus 2. Because on the left, it crosses out. And then I end up with 23 equals 15 times x plus 2. So what that really did for me was I was able to get the variable back in the numerator. And now I can solve this the way I would solve any of these. Distribute. Okay, bring over my 30. So I end up getting a negative 7 equals 15x. So x equals negative 7 over 15. I'm not going to worry that doesn't come out whole. That's not a big deal. Okay, I'm going to leave it just like that. If my stat lab wanted you to make it into a decimal, you would, but that's fine to do it just like that. And let's take one more. Let's do, now C and D are kind of interesting because they are actually proportions. And I could have actually solved B this way as well, but on this one I can actually, because this is a proportion, I can do cross products. Okay, it's only when you have a fraction equals a fraction, but I can say, okay, 2 times x equals 13 times 5. And likewise, over on this one, I could say x squared times 1 equals 64. Okay, so on this one, I would say x is plus or minus 8. Okay, so I could do that one like that. Okay, and this one I would say 2x equals 65. So x equals 65 over 2. It doesn't come out whole, so I can leave it like that. Or I could say x is 32.5, depending on how we're asked to leave it. So those two were proportions. So now they want, let me just put 2 little lines here, because now we're going to come back and do the one from before. I'm going to rewrite it here. And let's solve this one. Okay, so let me move this up a little bit for us. Okay, so now I'm going to multiply both sides by that whole denominator. So I'm really going to have, I'm running out of room here, but let's see, 0.05 times 232 times 169 plus 0.6n equals 600n. Okay, I multiplied both sides by this denominator. I really brought that over to the other numerator. Okay, after I do that, if I distribute, I'm end up going to get, after a couple steps, I'll get this. This is distributing, multiplying out this, and then distributing it to the 169 and the 0.6. Then I have 6.96n. And I actually have a linear equation, okay, so I'm going to bring over the n over there. And so I have 593.04n. Divide out that 593.04, and I end up getting n is about 3.306, which rounds to 3.31, which is exactly what we got when we did it graphically. So this is the number of beers that this person consumed to have that blood alcohol number of 0.05. So I'm going to post another video this week of just a few more examples of solving these kinds of equations, getting rid of the denominator the way we did. The next part of this activity we've already done really in another section, so I'm going to stop the video here. But we did already talk about horizontal asymptotes in in 5.1 and then again in 5.3. But take a few minutes to look at the next page of this. They're asking you for equations of horizontal asymptotes by looking at the graph.